Okay, so when you're looking at these problems, some of them are going to be straightforward and some of them require some extra thinking and steps. So right here we're given a cylinder which is a regular prism, so we can use the formula for volume of the cylinder. We're given the dimensions, how high it is, what the diameter is, and remember that radius is half of diameter. We're told that it's made of iron and we're given the density of iron. So that'll help us find the weight of the object. Since this is given to us in pounds per cubic inch, that means we're given weight density, not mass density. So if we look over here, remember we can find weight by multiplying volume times weight density, and that'll cancel out the cubic inches and leave us with pounds. So these are straightforward questions. What is the volume and surface area? We can use the dimensions with the formula to solve those. And then we'll use the given weight density of iron times the volume to find the weight of the cylinder. This question is referencing surface area. 1 quart will clean so many square inches. The fact that the units are squared tells you that it's an area, two-dimensional, as opposed to volume, which is three-dimensional. So right here we're dealing with surface area. In this question, we're dealing with weight. We need to know the weight of one cylinder to find the weight of 200 cylinders, and then to use the rate of dollars per pound to find how much it costs to ship all of those. In this question, we're told that the weight needs to change. So we're going to think back to what was the weight of one cylinder. Now this weight has to change. So if we're using the same material, iron, and the density, the weight density is not changing, but the weight needs to increase or decrease, well, that means the volume needs to change. So we're told in here that it's cut from the same stock. That means the radius or diameter is going to stay the same. So what has to change in the prism formula is the height of the cylinder. So H is going to change in order to make W equal 4.25. So in other words, what does H need to be to make W change to this number? And in this question, we're kind of just solving for a different variable. We're told that H must be 4.5. W must be the original number that we solved for. So they're asking for diameter. Now remember, in the formula you work with radius, and radius is half of diameter. But essentially they're telling you that this cylinder must either be thicker or skinnier when H equals 4.5 and W equals the original weight. So what must this be? Does it have to get thicker or skinnier? So you're solving for R right there. In this second question, that's asking about wood, it's also a rectangular prism, so it's a regular prism, so there's a formula for it. And here they're talking about 2x4s, but instead of 2x4, it's 1.5 by 3.5, because the term 2x4 represents raw material. Raw material is sent through a planer machine to make it all flat and smooth and with square corners, and that removes material. So a 2x4 might be 1.7 times 3.75, or it might be 1.5 by 3.5. But we're given the actual exact measurements so we can calculate the exact volume and weight. But just know that if you actually went to a store to purchase material and you looked for the 2x4s, that's what they're called, but that's not what they actually are. Okay? And so these are made of southern yellow pine. And when you're talking about wood, you're always talking about the average density, because the density can vary based upon which part of the tree it was cut from, but we're just going to use the average density for southern yellow pine, which is in pounds per cubic inch. So that's in weight density. So again, volume and surface area should be straightforward. You're finding the formulas for volume of a rectangular prism and the formula for surface area and plugging in the correct dimensions. Always make sure you answer in the correct units. Volume should always be cubed to the power of 3. Surface area should always be squared to the power of 2. And for the weight of the board, we first need the volume, and then we're going to use the weight density of pine to find the weight of one board. In this question, how much paint is needed to cover all these boards? Square inches tells us we're talking about surface area, okay? And gallons is talking about volume, but it's not asking us to solve for volume because we're told how much 1 gallon covers in surface area. So we need to find the surface area of one board and then multiply by this many boards and figure out how many gallons will cover that many boards in square inches. Okay, and then this question, we're talking about the weight of the boards. So we needed that weight density of pine times the volume of the board to find the weight of one board times this many boards times dollars per weight to ship it to find out how much to ship those boards. Okay. And in this question, we're given the dimensions of the board, but we're not given weight density. We don't know what kind of wood it is. So we know the volume of the board, or we can solve for it. And I'm sorry, we know some of the dimensions and we know the weight. Okay. So we have to solve for length. We're given width and depth. We need to solve for length. Okay. Okay, we're skipping number 3 and going to number 4. This one is trying to trick you a little bit because we know that this is a cylinder. However, it's not a solid prism. It's a hollow prism because it's a jar. So to find the volume of material in this jar, we could calculate the volume of the prism as if it were a solid, but then calculate the volume of the empty space because this empty space also has the shape of the cylinder. So we could subtract the volume of empty space from the volume of this as if it were a solid. So since we're given the dimensions of the solid object and we're given the thickness of the glass, we know the dimensions of the inside empty space because we're just going to subtract the thickness of the glass, which is 3/16. Then we can find the volume of the amount of material. For some of these questions, we need to employ that literary technique of suspension of disbelief. I'm sure you've heard your English teachers talk about that because we have to believe that as this jar sinks into water, it sinks down and stays vertical without tipping over. So let's just pretend it does for the sake of solving this question. If you read this part at the top, we were talking about boats and boat design. Why do boats float instead of sink? That's because of density. You have to weigh more than the water that you're displacing in order for you to sink. So if a boat is floating in the ocean, that's a lot of water. So however much water the surface area of that boat is displacing as it sinks down, it's displacing its own weight in water. Okay? So if you sink, or if you're in water and you sink down, your weight is equal to the weight of water displaced. Okay? So if we find out how heavy this jar is, it will displace that same weight in water. Okay? So the question is, how far does it sink down, assuming that it doesn't tip over if it's sitting into the water? So to solve that, you have to take into factor the density of water. And that's the average density because salt water and fresh water might be different, but we're going to use this number right here. So we can see that the glass is more dense than water, so therefore it's going to sink, but it's only going to sink down until it's displaced its own weight. So once it sinks down, assuming it doesn't tip over, the shape of the water that it's displacing is also in a cylinder. So it will displace its own weight in water, and since that shape of the water is also cylindrical, you can find the volume of the water and then you can solve for H and it'll tell you how far the jar sinks. Okay. Now here's a little bit of an extra challenge. What if we fill the jar up halfway with honey? Okay. So the honey is also denser than water, so that means it sinks. And so basically the honey is adding to the weight of the jar. If the jar is half full, you can figure out what the volume of the honey is and then use that volume and weight density to find out how much the honey weighs, and then how far will the weight of the jar plus the honey sink down into the water.